Okay, this is how to teach the long division. This is how to teach long division. Students, first off, they must be familiar with the base 10 blocks and with making trades, such as trading 110 for 10 ones or 100 for 10 tens. Students also, prior to this lesson, should be familiar with the way to write division, such as 24 divided by 3 equals 8. They know that, but prior to this lesson they should understand the long division format. Okay, so to get them to do the long division algorithm, which is basically a problem such as this right here, except solving it completely abstractly, we're going to begin in the concrete, understand long division in terms of the concrete, and then see how the long division algorithm mimics what happens with the concrete items. So for example, we might ask the students to do just a few problems on their own, however they'd like to do them. And so, like for example, here's a problem 334. We could ask the students to break them into two groups, and we should observe them as they're breaking them into two groups. So the students are working with this. I might have this on the document cameras for us to talk about later, but the students would have the base 10 blocks, and they'd represent 334 in this case. And I would ask them to break into two groups. Now students are going to do this in a lot of different ways, and you aren't really directing them how to do it. So some might just take two there and break them up like this, and here's a group and here's a group, and say, okay, here's a group and here's a group. Right now I don't know what to do with that, and here's a group and here's a group. Right now I don't know what to do with these, and then break this into 10 tens and break this into 10 ones and split those apart too, and that's fine. You're just trying to get them to divide with these larger numbers using the base 10 blocks. So they do maybe a couple problems like that, and you discuss how they're doing it. Okay, and some might do it this way. There are a lot of various ways that they might go about doing it. Once they finish the problem, you're going to write the answer, like in this case. The answer would be 167. So they are going to write it in the long division format, but they haven't solved it here. They solved it here with the base 10 blocks. They're just writing it in this format. And again, hopefully this format they've already seen prior to this day's lesson. So they do maybe one or maybe two or three problems just like I showed you here, doing it however they want. And as you go around, it would be very, very helpful if one of the students happen to go through a process where when they divided, like for example in this problem here, when they divided it, they began with the largest blocks and they got rid of all the largest blocks before moving to the next largest blocks. So for example, if they began by saying, okay, this goes into one group, this goes into one group, oh, I got to get rid of this before I begin dividing those, so I exchange that for 10 sticks, or 10 tens, or 10 rods. Okay, so I make my exchange, and now I deal with the rods, with the tens, and I divide those two ways. So 1, 2, 3, 4, 5, 6 goes up here, and 1, 2, 4, 6 goes here. And then before dividing the cubes, I say, okay, I gotta make this into 10 tens, and I do that. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, and then I take these and I divide them two ways. If a student is doing it that way, you would want to highlight that for your class, because that's what you're going to want the whole class to do it that way. You let them solve the problem however they want it for the first two times, and you're looking to see if anybody has solved it this way. Okay? If they have, the next few problems, you want to have the students solve it this person's way, exactly the way I did. Get rid of the biggest blocks first, before, and then making trades, and then the next biggest blocks, make trades, and then the smallest units. Okay? If nobody does that, then you're going to have to show them and suggest, here's another way to try and do it. And you suggest that you want them to try a few problems like that. So exactly what I did here, you'd give the students the problem, in this case 334, and you'd say, here, try it this way. And you'd have the students do it this way. It's very important that they're able to do it this way because the long division algorithm mimics what I just did here. And we want the students to complete the long division algorithm by recalling what they did here. Okay, so this experience is going to remind them what steps to do next. Okay, so you give them maybe 2 or 3 problems, asking them to complete them in this way. And again, all they're doing is they're just writing the answer down. They're just writing it in this format, the initial problem, and then writing the answer, but they're solving it the way I showed you. It's important that they understand how to solve it in this manner. Okay? So now we're coming to a point where we want to have the students moving from solving in the concrete way to finding these answers in the concrete to finding them in the abstract way, in the written long division format. So we present a problem, and in this case, we want them again to use the same procedure, but we want them to stop. And we together as a class are going to go stopping step by step, stopping at the end of each step, and then comparing it to what's happening here in writing, and if they could perform the same functions in the writing. Okay? So for example, let's say we had 675, and we want to divide it into 5 groups. So we'd have the students say, okay, let's prepare to do this. Okay, and I'm missing one of 100, so imagine that there's 100 there. Okay, and we're imagining that there's another 100 here, which I happen to not have here, so maybe I'll just use this as 100. Okay, so we have 675, and we ask the students, okay, what's the first thing that you do in this process? Okay, and I might have this, by the way, on a document camera or a smart board that they could see everything. Okay, so what's the first thing they're going to do? And they're going to say, well, the first thing we do is we divide this into 5 groups. And I'd say, okay, go ahead and do that. So they put this into one group, this into one group, this into one group, this into one group, and this into one group. And we're going to stop right there. Okay, I'm going to say, okay, now stop. I'm going to go over here, I'm going to say, okay, which of these numbers reflect what you just did? Okay, you broke apart the hundreds. Where are they here? And that's this number 6. Okay, and you broke them into 5 groups. Which 5? Is it this 5 or is it this 5? And they say, okay, it's this 5 that indicates the 5 groups. Okay, and what went into each group? 1. Okay. See, now they're looking at this as saying, okay, that represents one of the 6 of these, okay, and this represents the number of groups, okay. So you could say, okay, so from the original 6, we originally had 6 of these here in the center pile. We took away how many? And then we took away 5. Okay, so we took away 5. Okay, so we have 5 groups of 1, really, and 5 groups of 1. What is that mathematically? 5 groups of 1 is 5 times 1. That's where the 5 times 1 comes from. Okay, so we take that away, we're left with 1. Okay, so let's go on to the next step here. So now we have this situation here. There's our 5 groups, and so far we divided the hundreds. What do we need to do next? And of course the students will say, okay, we've got to trade this for 10 tens. Okay, so we go ahead and we do that. 2, 4, 6, 7, 8, 9, 10. Okay. Okay, and say just stop. Every time they do a physical action, you want them to stop and say, okay, so where was that 100 in here that you just broke up? Is it this one up here? And the answer is no, that's what's in these groups. Okay, it's this one down here. And so what did you do? You made this from 100 into 10 tens. Okay, so let's go back to this. So how many total tens do you have now? You have 10 here and 7 here. You have 17. Okay. Can I come over here? Can I figure that out over here? Where are those numbers here? Well, there's the 10 tens here, and there's the 7 here. Okay, so that 7 goes with those. So let's just add them together because we have a total of 17. Okay. All right, let's go back to the concrete and say what's the next thing that you do. And it is we want to break these into 5 groups. Okay, can you figure out how many each group's going to get if you have 17 of them? And the idea is saying, okay, 17, 5, it looks like there's going to be 3 that's going to go into each. Okay, so we, again, every time we do one physical movement, we say, okay, let's stop. Where would that be over here, what you just did? Okay, and there, here it is, 17 broke into 5 groups. Everybody got 3, so 3 tens, okay? So we took away from the 17, we took away 1 group of 3, 2 groups of 3, 3, 4, 5 groups of 3. 5 groups of 3 we took away, or we took away 15. Okay, we had 17, we took away 15, and we're left with 2. So 17 minus 15 is 2. All right, let's return back to this. What's the next step? The next step is to change this in to 20 units, 20 singles. So we do that. Okay, let's stop. We have 20 here. I only see 2. What happened? Well, we took 2 tens and made it into 20 singles. Okay, 20 ones. And now how many total ones do we have? We have 20 here and 5. We have 25. Okay, how could I figure that out in here? Well, it looks like that 5 there goes with that one there. Those are the ones. Those are the 5 ones we had over here. And these are the 20, so they come together, so there's 25. Okay, all right. Now what do we do? Okay, we break that into 5 groups. And can they tell me how many is going to go into each group from this? And hopefully they'll say 5, because here we are in 3rd grade and 4th grade. So how did you get that so fast? Well, they know 5 times 5 is 25. Okay, so they go ahead and they do that. Oops, looks like I gave them too many on this one. 2, 3 is 5, 2 and 3 is 5. Okay, so each gets 5. So from the original 25 we had here, we have nothing left. What happened here? Well, we took away from the 25 we had here, we took away 25, or 5 groups of 5. There's a group, 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 5 groups of 5, and we're left with 0, and there's nothing else to divide. And our answer is 675 divided by 5 is 135. And we can check that here, 135. Okay, so what we want to do is, just as I did here, you want to present them with at least 2 more problems, doing the same thing, the stop thing, and coming up here and doing this. And you're trying to get them to keep asking them, okay, where in here is the physical action that you just did here? Because you want them to see as this imitating this. And if they can do this and they remember what they did here, they can translate those directions over here. Okay? So that's basically what we want to do for another 2 or 3 problems, again, as a class going through it. Okay, then there comes some point where you say, okay, do you want to try it in writing first? I mean, would you like to try a problem like 512 divided by 2? Do it in writing first, over here, and then check it with your manipulatives. And see if your answers agree. If they don't agree, look over here and look over here and see if you can find where you made the mistake. So you're empowering them to figure out their own mistakes. You're also connecting now the concrete to the abstract, just like we did here. Okay, but we're going to begin with the abstract first and check it with the concrete, because that's where we want to go. We don't want to keep using these for the rest of our school year or our lives. We want to be able to do it this way. Okay, so they go ahead and they do it this way. They check it here. If they get the right answer, that's terrific. If they don't, you can help them, or they might be able to figure out where they got what they forgot to do. Maybe they forgot to trade in one of these for 10 tens. Okay, you just don't know, but it's up to them to figure it out. Okay. Now you can also do this with simpler problems. You don't have to begin with 512. You could begin with 12 divided by 2, or really maybe something a little bit more complex, like 54 divided by 3. So you could do exactly what I did here, the entire process, except begin with something like this. If you thought your students weren't ready for something like this, and they really should be ready in 3rd grade and 4th grade for sure, they should be ready for this. But in case your students struggle in math, you might start with something like this and begin with this in the exact same process. Don't forget to challenge the students with a 0. Remember, anytime there's a 0 in a problem, such as 504 divided by 2, there's going to be issues. Okay? So again, you want to, maybe at this point you'd say, okay, try that in writing and check with the manipulatives. And if they get it right, terrific. If they don't, okay, they can go to the manipulatives and see what they have to do to make this right. That's what you're really doing. You are really empowering them to figure out things on their own, to analyze and evaluate. Okay, and that's what we have. That's what we're doing here. This whole way of this whole process, you can see it begins in the concrete, moves to the abstract. It's contextualized. We're understanding the concept first. For example, why we bring the 7 down here. Okay, we understand the concept here, where that 7 is, what the 1 is, why we're subtracting here, for example. We're doing analysis and evaluation. When I ask the students, hey, take a look at this. Where is this from here that we had it over here? Where's that over here? And what are we doing here? What should I do over here? Okay, and then when they're also checking their work, they're analyzing and evaluating. If they make a mistake or they get it right, they're coming over here and looking at the base 10 blocks. Okay, you can see there's a lot of patterning involved. We're going to start to see a pattern that's going on, which you can talk about later. You can talk about, okay, you look at this divided into this, and then that times that goes there, and then subtract. And then and then make that into a 10, and then 17, and then do the same thing. This goes into this, that times that is that, subtract. As the students, by the way, are working on this, especially when they first begin to work on a problem abstractly for the first time, and then check out the manipulatives, when you're walking around, you should hear them talking about the problem in terms of the manipulatives. Like, for example, this 512 divided by 2, if you hear any of them talking out loud about this, they're going to say, okay, that's like, they might say something like, oh, that's 500s, that's 5 of these, for example, and I got to break them into 2 groups, and they're just kind of visualizing these things here. That's why we did this here. That's why we spent so much time here understanding the process in a real-world setting with the manipulatives, because then when they come over here, those experiences, which are very memorable and very powerful, they guide them. They tell them what to do next, and that's what they do. So they immediately interpret this in terms of the concrete. They say, okay, it's like having 5 of these, dividing into 2 groups. So that means each group's going to get 2 of those, and 1's going to be left. You might even see them begin to skip steps because they're going to understand this process so well. And that's a good thing. That, for example, in this case, you might say, okay, that's 5 of these hundreds, divided into 2 groups. That means each group gets 2 of those, and that means I'm going to have 1 left. Okay, they don't even have to go through the process of subtracting, of multiplying and subtracting, because they understand the concept so well. That is a big plus. That tells you they understand what this math means. And then they might say, okay, so that becomes 10 of those 10 tens, and that means I have 1 10 there, so that means I have 11 of those 10s, or 11 of those rods, or 11 of those sticks, divided into 2 groups. That means each group's going to get 5. So I'm going to take away 10 from there. I'm going to be left with 1. You might see this kind of writing there. And they understand it. They don't need to go through all these steps that we had to go through. Because we had to go through this because we didn't understand any of this. And it was just memorized procedures. They aren't going to memorize it. Matter of fact, right now, I'm not memorizing anything. I'm just thinking about the real world items. And that's what's guiding me to the next step. I'm not saying, oh, what's the next step? The next step is to multiply and subtract and blah, blah, blah. I'm not doing that. I'm just saying, okay, there's one of these 10s left, and I'm visualizing this. I'm saying, okay, that means I have to make it into 10 little 10 little cubes. And so that's 10 little cubes and 2 cubes. That's 12 little cubes. Divided into 2 groups, that's 6. And I know I've got nothing left. And they could have this, and they could understand it better than most 3rd or 4th grade teachers understand what this process is, who have been teaching this for years, because most 3rd and 4th grade teachers don't understand what we're doing and why we're doing it. These students will.